So what we're going to do now is we're going to go ahead and take a look at the StreamGangs folder. And you can see this is where all the different implementation strategies reside. There's a whole slew of them. This overall program is based on a class called StreamGang, which is a framework I've developed and used for a number of years that allows getting input from a bunch of different sources. In this particular case, it's getting the input from the files that correspond to the works of Shakespeare, but you could also get it from a network, you could get it from a GUI, you can get it from lots of different places. And then it goes ahead and it runs various strategies in a way where we can treat them and compile them and test them in an apples-to-apples comparison way. Now, a lot of the features of the StreamGang framework are actually not used in this particular program, but just real quickly, there's this base class that has some hook methods like, or a superclass called getInput that returns the input, which in this case is going to be this, this list of elements, which in our case will be the works of Shakespeare. And there's some other stuff in here that I'm going to skip over, but the key method here that's important is called InitiateStream. And that's the hook method that starts all the wheels in motion for a particular implementation strategy. So this is a hook method that starts the StreamGang processing for a particular implementation strategy. And those implementation strategies, of course, are going to be implemented by the subclasses that inherit indirectly from StreamGang. So StreamGang framework's used by a lot of my tests. What's interesting here, of course, is the SearchStreamGang. And that is also an abstract class. It's not the root of the hierarchy. It's inheriting from StreamGang, filling in the fact that we've got basically a list of care sequences, which are the works of Shakespeare. And this is really then the superclass that's implemented by all the different subclasses, like the search with parallel streams, or search with reactor, or search with arcjava, or search with sequential streams, search with sequential loops, et cetera, et cetera, et cetera. So this is where the specific features for this particular family of applications come into play. It also stores some important fields that are used by all the different strategies. So the phrases we're looking up, we have an iterator to the list of works of Shakespeare, so we can dole them out one at a time. Those things get initialized in the constructor for this abstract class. And then there's a method called getNextInput, which is called by the underlying framework to try to see if there's any more processing to be done. If there is not, we're finished. Otherwise, we start going through our iterator. And then here we have kind of the brains of this callback-driven code, which is InitiateStream. This is that abstract method that was defined in the StreamGang superclass, super-duper class, because it's the base class of all the hierarchy. And in this case, what we do is we're going to go ahead and time how long it takes to run this implementation's process stream method. And we'll talk more about that in a second. That's the hook method into all the different implementation strategies. And then we pass a tag in here, and the tag is actually defined in StreamGang, and it's done in a way where it's actually going to have the real name of whatever the subclass is. So this is how we keep track of what test is being run without having to hard code that into our code. We just use this little trick by using the tag. And that call, we'll look at the way the timer works. The timer is super cool. That's going to go ahead and run the particular strategy, time how long it took to run, and it's going to return a lists of search results. We'll talk more about what that means later. And then we go ahead and we print those results. And that's what actually prints out what you see here, where it says for this particular test, like search with sequential loops, the search returned 42 phrase matches for 38 input strings. That's where that particular printout takes place. And I won't go through all the details here, but we're basically going and figuring out how many matches occurred in our program. What I do want to focus on at this point, though, is Runtimer, because Runtimer and the Timerun method is super cool. So you'll notice when we want to time something, we pass it in as a method reference. And here's what we're passing it into. So here's the Runtimer class, and it's a very simple class that simplifies the computation of a bunch of successive execution times to see which ones run the fastest. So the way it works internally is we have a map that maps the string to, the string is the name of the test that we're running, to the long, which is the amount of time it took to run, in this case in milliseconds. We keep track of the start time and the execution time. We have a couple helper methods that say start timing, which sets start time to the nano time. And then stop timing basically takes a snapshot of the current nano time. And when we subtract the start time from the current time, it tells you how long it took to run. There's a couple of different time run methods. You can see the one that we used when we passed it in here was this one, Runtimer time run. And this is going to take, as you can see when we click on this, this takes a supplier. So if you recall what we've talked about earlier about supplier functional interface, the supplier functional interface has a single abstract method called get. And the way this works is we start timing. We then call the get method on the supplier, which in our case is going to go ahead and run that particular implementation strategy for parallel streams or sequential loops or RxJava or whatnot, get the result back, and then stop timing. And then we go ahead and we enter into the map the name of the test and the time it took to execute. So when we're all finished with running all those different implementation strategies, then we're going to be able to see how long everything took to run. And we'll come back and take a look at that in a little bit. Okay, so you can see here that we call print results, and that goes ahead and prints everything out here. And this will also, as we'll see, this will also go ahead and display the results. If you go back up here to the SearchStreamGang test program, and you look down in run test, you'll see the last thing it does here is it says run timer, get timing results. And that's also a method that's defined in the Runtimer class. And you can see what get timing results does. It's really very, very clever. It uses a string builder, and it's what's going to display the results that we see here, printing 15 results from fastest to slowest, and then it prints out the time in milliseconds needed to run each of the different tests. So that's what the output looks like. Here's how the output's produced. It's also pretty cool. We use a string builder just to kind of build this thing up as we go and return it as a string when the call is made, so you don't have to print it as you go. You can return a string and then do something with it later. So here's what we do. We take the results map. Remember, the results map was mapping the name of the test, like search with parallel streams, to the time required to execute the test, which is the long value. So we say results map, go ahead and convert the results map into an entry set. So now we have a set that maps the string long. So we have a set of these things. And then we convert that set into a stream. So now we have a stream of map entries containing strings and longs. Again, the string is the name of the strategy that's being run or was run, and the long is the time it took to run in milliseconds. The next thing we do here is we go ahead and we use the map method, and we take the value, which was the time it took to run, and the name, which was the key, which was the test we were running, and we swap the order because we want to have the time first followed by the key. And so to do this, we make something called a simple immutable entry, which is just a tuple that contains a value followed by a key as opposed to a key followed by a value. And then we go ahead and we sort this stream by key. So now we're sorting by the time taken to run, which, as you can see over here, we'll end up sorting it in ascending order in terms of fastest to slowest. And then what we do is we terminate this particular stream with a for each method, which will go ahead and append the time it took to run, which is now the new key in this particular variant, because we swapped the order of the key and value that we had from the original map. We go ahead and we print that out in a formatted way, so it'll right justify the numbers. And then we go ahead and get the last segment, which is just basically getting the name of the test. And so when we're all done, we append everything together, and that's what gets printed, and that's what gets put out here. And the way that that gets sent back to us is we take that string builder and we convert it into a string, and that gets returned to the caller, and we just go ahead and print that. So that's kind of showing you how the some of the key parts of StreamGang work. Let me go back to SearchStreamGang real quick So I wanted to show you how the timer worked. And then the final method down here, which I'll just point out real quickly. This is also covered in other videos, but it's a neat example of some other powerful streams mechanisms and modern Java mechanisms. This is called print phrases. And this will go ahead and print out for each work of Shakespeare, like the tragedy of Hamlet or the tragedy of Julius Caesar, lots of tragedies. It'll print out the name of the play, the name of the work, followed by all the different phrases that happen to match in that work. And the way we're going to do that is we're going to go ahead and take the list of search results we get, convert it into a stream of lists of search results, flatten that stream so we just have a stream of search results, and then we collect that into a hash map, actually in this case into a tree map, so it's sorted. And then we go ahead and print the results out. So I'll come back and show you that later when we get a little further along and we looked at some of the implementation strategies and we've got a chance to run the program.